In this video, we're going to take a look at discrete random variables. In your formula booklet, you are given one formula. The expected value of a discrete random variable x. So E of x is equal to the sum of all the values of x times the probability of x being that discrete random variable. But what do we mean by a discrete random variable? A discrete random variable is one which may take only a countable number of distinct values, such as 0, 1, 2, 3, etc. If you rolled this dice, the discrete random variables would be 1, 2, 3, 4, 5, and 6. You could draw a table to represent the possible outcomes. Capital X represents the variable. In this case, it is the score on the dice. Little x represents the actual outcomes. In this case, 1, 2, 3, 4, 5, 6. So capital X is equal to the score on the dice, and little x is the list of outcomes 1, 2, 3, 4, 5, 6. If you flipped two coins simultaneously, you might be interested in the number of heads you received. You could possibly get 2 heads, 1 head, or no heads. In this case, capital X equals number of heads, and little x is the outcomes, which could be 0, 1, or 2. You could then draw the following table for your discrete random variable or probability distribution. X is the list of possible values, and it could take 0, 1, and 2. Then you could write the probability that big X is equal to little x. They are the probability of each value, and in this case they would be a quarter for 0, a half for 1, and a quarter for 2. The probabilities of this distribution are: the first property is that the probability of x equaling x is between 0 and 1, and the second property is that all the probabilities add up to 1. Let's go through some questions. Question 1. The table shown represents the probability distribution for a spinner. So x can take the value of -1, 0, 1, 2, or 3. The probability that x lands on x is -1 is 1/5, 0 is A, 1 is 1/10, 2 is A, 3 is 1/5. A. Find the value of A. Well, we know that all the probabilities must add up to 1. So therefore, 1 is equal to 1/5 plus A plus 1/10 plus A plus 1/5. Therefore, 1 is equal to 2/5 is equal to 5/10 plus 2A. Therefore, A is equal to 1/4. Part B. Calculate the expected value of x. Well, we know that the expected value of x is equal to the sum of x times the probability of x equaling x. So in this case, we have got minus 1 times 1/5 plus, we know a is a quarter, so a quarter times 0 plus 1 times 1/10 plus 2 times a quarter plus 3 times 1/5, which is equal to 1. Part C. If the spinner was to be used in a game, what should be charged to make the game fair? Well, in order to make the game fair, nobody should win and nobody should lose. An expected value of 1 means that every time I play that game, I would expect to be $1 up. So if I had to pay $1 in order to pay that game, nobody would win and nobody would lose. So over a long period of time, I would keep paying $1 to play and I would keep winning $1. So therefore, the game would be fair. So the price that needs to be charged is $1. Question 2. A spinner has 6 sections, A, B, C, D, E, F. The table below shows the area of the spinner occupied by each section and their respective payoffs. So section A has an area of 2/7 and a prize of $6. B has an area of 5 21s and a prize of $5. C has an area of 4/21 and a prize of $4. D has an area of 1/7 and a prize of $3. E has an area P and a prize of $2, and F has an area of 1/27 and a prize of $1. A. Calculate the value of P. Well, we know that all the probabilities must add up to 1. So the areas must add up to 1. So therefore, P is equal to 1 minus 2/7 plus 5/21 plus 4/21 plus 1/7 plus 1/21. So P is equal to 1 minus 19/21. So P is equal to 2/21. The game costs $4. B. Calculate the expected profit for playing the game. So the first thing we want to do is let X equal profit. Now we need to calculate the expected value of X. Well, that is equal to the sum of X times the probability that X equals X. So therefore, the expected value of X is equal to 6 times 2/7 plus 5 times 5/21 plus 4 times 4/21 plus 3 times 1/7 plus, well, we know what P is, so we've got 2 times 2/21 plus 1 times 1/21. When you calculate that out, you get E of x is equal to 36 over 21 plus 25 over 21 plus 16 over 21 plus 9 over 21 plus 4 over 21 plus 1 over 21, which is equal to 91 over 21, which is equal to 4 and 7 over 21, which is equal to 4 and 1/3. That means the expected profit is 1/3 of a dollar, because you are, which is 33 cents. Question 3. 5 cards numbered 1, 2, 5, 5, and 6 are identical when placed face down. Throughout this question, a card is drawn randomly. The number is recorded, and then the card is replaced, and the 5 cards shuffled before a new card is taken. Let X denote the value shown when one card is drawn. Complete the following probability distribution table for X. Well, X could take the values 1, 2, 5, or 6. Well, the probability that X equals 1 is the same as the probability that X equals 2, which is the probability that X equals 6. And they are equal to 1/5. The probability that X equals 5 is twice the probability that X equals 1, or the probability that X equals 2, or the probability that X equals 6. So the probability of 5 is 2/5. Part B, find the expected value of X. Well, we know that the expected value of X is equal to the sum of X times the probability that X equals X. Therefore, the probability of the expected value of X is equal to 1 times 1/5 plus 2 times 1/5 plus 5 times 2/5 plus 6 times 1/5, which is equal to 1/5 plus 2/5 plus 10/5 plus 6/5. When you work that out, the expected value of X is equal to 19 over 5. So the expected value of X is equal to 3 4/5. Let Y represent the sum of the values when 2 cards are drawn. C. Complete the following probability distribution table for Y. The first thing we need to do is find out all the possible values for Y, and the easiest way to do this is to draw a sample space. I can now see Having drawn a sample space, all the possible outcomes, which are 2, 3, 4, 6, 7, 8, 10, 11, and 12. I can also use the sample space to calculate the probabilities, giving me 1 out of 25, 2 out of 25, 1 out of 25, 4 out of 25, 6 out of 25, 2 out of 25, 4 out of 25, and another 4 out of 25, and 1 out of 25. And part D, find the expected value of y. Well, I know that the expected value of y is equal to y times the probability that y equals y, so the expected value of y is equal to 2 times 1/25, which is 2 out of 25, plus 3 times 2 out of 25, which will give me 6 out of 25, plus 4 times 1 out of 25, which is 4 out of 25, plus 6 times 4 out of 25, which is 24 out of 25, plus 7 times 6 out of 25, which is 42 out of 25, plus 8 times 2 out of 25, which is 16 out of 25, plus 10 times 4 out of 25, which is 40 out of 25, plus 11 times 4 out of 25, which is 44 out of 25, plus 12 times 1 out of 25, which is 12 out of 25, which is equal to 190 over 25, which is equal to 7 and 15 over 25, which gives me a final answer of 7 and 3/5.